Hello students, welcome back to Physics Wala. So in today's lecture we are going to discuss about relations and functions. The very first topic in this summary series, right, which will be very useful for your class 12th board preparation. Alright people, so today in relations and functions, first of all what are we going to discuss? Okay, so we are going to discuss what all the relations we are having, right, what all the functions we are having, and different applications on relations as well as functions. So in relations we have reflexive, symmetric, and transitive, and from these three we'll go for equivalence, right? So there are different applications on that. And functions, no need to say, lot of types of functions, right? And a few of the applications, few things that you have already learned previously in class 11th, okay, but which we're not going to cover it again now, right? We'll be discussing about the main 12th portion of relations and functions, okay, right? And coming to the weightage, people, right, as you know that we don't have any defined rule that yes, this particular 2 marks or 4 marks or 6 marks questions will come from this chapter. We don't have such rules for CBSE, but when we take the statistics of last few years, okay, so it's like almost sometimes it may be 6 marks or 8 marks from this chapter, okay, total. The total 80 marks of paper, you'll be having 4 marks or 6 or 8 marks, like 2 into 4 marks, 2 4 marks questions you may have, or 1 2 marks and 1 6 marks question you may have, or only 1 6 mark, or 6 mark, and you may have some choose the correct answer of 1 mark, right? 1 mark short answers, right? So it depends on paper to paper, but definitely I can say that definitely 2-3 questions are appearing from this chapter, okay, directly from the relations, or mainly from the functions, that too, finding f of f circle f, g circle f, f inverse, right, f inverse circle g inverse, right? So we can see major questions from functions, and from relations some statement will be given, and we need to find whether it is equivalence relation or whether it is only transitive, only symmetric, only reflexive, like that, okay. So we are going to cover all those in today's lecture, okay. So we'll be having some discussion on the synopsis part, okay, very fast discussion. Will not spend hours and hours on that, okay. So in hardly 1.5 hours we'll be completing the chapter, right? So what is the definition of a relation, people? So before going to relation, first of all you need to understand what is A cross B, right? That is Cartesian product, all the ordered pairs of A comma B, okay, all the ordered pairs of A comma B. So set of all those ordered pairs, we call it as Cartesian product, right? So any one or any small subset of that, can be considered as a relation, okay. Any subset of that can be considered as a relation. In Cartesian product, let's say we have 20 elements. You just pick one element out of that and just write in the brackets. That is enough to say that it is a relation. Any one, or at least you want to keep 5 elements, okay. You want to keep all the 20 elements, okay, fine. No problem, nothing is a problem, okay. But any subset of that can be considered as a relation, okay, right? So thus a relation is from A to B is something like R subset of A cross B. Relation is always a subset of A cross B, okay. The same thing, set of all A comma B ordered pairs, where A is the first element in the first set, B is the element in the second set. And what do we call this first set, second set? We'll see that, okay, right? So that is a basic definition of a relation, okay. So people, if we have 2 sets A and B, and in A, let's say we are having P elements, and in B we are having Q elements, so the number of ordered pairs will be getting is PQ. The number of ordered pairs will be getting is PQ, and as we are having PQ elements inside that Cartesian product, so the number of relations have a formula 2 power n. So 2 power PQ will be number of relations from A to B, where A is having P elements, and n of A cross B, n of A and n of B. So n of A is P, n of B is Q. So the total number of relations we'll be having is 2 power pq. The number of relations we'll be having is 2 power pq. I hope this is easy understandable for you, right? Okay, right. So what is the domain of a relation? What is domain? What is range? What is codomain? The same set of things we'll also discuss for function. Again, there is a difference between a relation and a function. Relation is different, function is different. Okay, don't compare, or I mean to say, don't confuse and bring function to relation or relation to function. I'll tell you which type of relations cannot be considered as a functions. Okay, that I'll tell you when we are discussing functions. Okay, so you can see here. Okay, if R is a relation from A to B, the domain of relation R is set of all the elements A belongs to A. So in that Cartesian product, whatever we are taking, so all the set of all the first elements, let's say we have 1 comma 1, 1 comma 3, 3 comma 4, like that. Okay, set of all the first elements. So domain here will be 1 comma 3. Domain here will be 1 comma 3. Just set off all the first element. 1 repeated twice, but don't worry, it is enough to include ones. Okay, no need to include the repeated value again and again in the set. Okay, right. And what about the range? Range is set off all second elements. Okay, so in the ordered pair you can see in the 1, this is 3, this is 4. The set of all second elements. Okay, so then B, which is an element in B, such that A comma B belongs to R. Okay, in that relation, okay, all set of all second elements, we say it is a range. So when domain and range are clear, now come to the confusing term, that is codomain. Always codomain and range will fight each other. I mean to say, you fight yourself by doing mistake among these. Okay, remember the second set, whatever we are having, the set B, when we are talking about A cross B, the second set B has this complete B will come under codomain. The complete set B is called codomain. But when you go to relation and when we list only the second elements, that comes under range. So range and codomain are not the same. They may be equal in few cases, they may not be equal, but those two are two different things. You need to understand that. Okay, range and codomain are two different things. Okay, so what next? Empty relation. The name itself says that empty relation. That means we will not have any elements in that relation. We say it is called empty relation or a void relation. Okay, will not have any elements in that relation. Are you understanding? Okay. You know what is empty set? No elements in that. Number of elements will be 0. But still it is considered as a set. You cannot say that, so no elements is there, so why to name them? Why to name or why to keep it a separate set? We need to because we need to differentiate that with the remaining set with elements. In the same way, in the relations also, if the relation has no elements inside that, then we say it is empty relation. Okay. For example, I have set 1, 2, 3, and here let's say 10, 11, 12. Okay. And the relation I'm giving is x comma x square. The relation I'm giving is x comma x square. That means I need to have the ordered pace x comma x square. For 1, square is 1 square. Do you have 1 square? No. For 2, square is 4. No. For 3, the square is 9. Elements are not there. So you cannot map them, right? You cannot map them. So that's the reason it is called empty relation, or you say void relation. Okay. Next, universal. Universal relation means that is the parent, that is the big, that is the ultimate. Okay. So a relation R from A to B is said to be the universal set if R is equal to A cross B. That means all the elements of Cartesian product should exist in the relation. Okay. All the elements of Cartesian product should exist in relation. Then the relation is called universal relation. That relation is called universal relation. Okay. Next, identity relation. Identity, For example, you have an identity card. So what exists in ID card is your own details, right? Your own photo, your name, and your phone number or whatever. That means my details, right? So it's like A to A, okay? It's like A to A, and if you have A to A comma B, and if we say that is an identity relation, definitely that A and B should be equal, okay? So it's simply like A comma A. The element should be like A comma A, 1 comma 1, 2 comma 2, 3 comma 3, like that, okay? So that comes under identity relation. The next we have reflexive. So in reflexive, you know, A comma A belongs to R. For all A belongs to A. For all, see, in the previous thing, we didn't say it for all. I mean, we have for all A belongs to A. So what is the difference between identity and reflexive? Carefully see, what is the difference between identity and reflexive? See, here, a relation R defined in set A is set with the identity relation A if, sorry, there is some printing mistake happened here. Okay, thus identity relation R is equal to A comma B such that A belongs to A, B belongs to B, B belongs to A, and A is equal to B. Okay, see here in reflexive we should have only those elements A comma A. Okay, so reflexive is like 1 comma 1, 2 comma 2, 3 comma 3. Okay, symmetric relation is like A comma B. If A comma B is there, B comma A should be there. If A comma A is there, B comma A should be there. Okay, people, there is some mistake that has happened here. I'll try to rectify that. There is some printing mistake. Please cancel this. This should actually come to the reflexive. Okay, this should actually come to the next reflexive. Right? See, I'll say like this. For example, I have 1, 2, 3 elements. Okay, I just write 1 comma 1, ordered pair 1 comma 1. So is it identity? Yes, it is identity. It is identity. No matter you leave 2 and 3, it's okay, no problem. But in reflexive, definitely should have 1 comma 1, 2 comma 2, and 3 comma 3. It should be there. All the elements should be there. That's what I'm saying. There's some printing mistake here. Okay, just leave that. So all the elements should be there in reflexive relation. But even if you have one, that can be considered as identity relation. Okay. So in reflexive, it is for all A belongs to A. It's like for all A belongs to A. Okay. And next we are having symmetric relation. Symmetric, again for all A comma B. Whenever you have A comma B as an element in the relation, B comma A should also exist. Okay. So the set is 1, 2, 3, 4. From 1, 2, 3, 4, 1, 2, 3, 4 we are going. I have the elements 1 comma 2. Okay, 2 comma 1, 3 comma 2. So I am asking, is this a symmetric relation? Is this a symmetric relation? Tell me. No, this is not symmetric relation because, okay, for 1 comma 2 you have 2 comma 1. But for 3 comma 2 you don't have 2 comma 3. Okay, the symmetric 2 comma 3 is not there. Now, if I add that element 2 and 2 comma 3, then I can say that yes, it is reflexive. It is a reflexive relation. Are you understanding? Sorry. It is a symmetric relation. I'm so sorry. It is symmetric. Okay. Next, transitive. In transitive, we go for 3 elements. Like if we have A comma B in the relation and we have B comma C also in the relation, then we should have A comma C. Like let's say 1 is less than 2 and we know 2 is less than 3. So we know that 1 is less than 3, right? So this is a transitive relation. If AB is there, BC is there, A comma C should be there, but not always. Not always this property will be valid. Not always a relation is reflexive. Not always it is symmetric. Not always it is transitive. No, we cannot get that. Right? It depends on the given question. It depends on the given sets A and B. But if a set happens to satisfy reflexive, symmetric, and transitive, without any doubt, we can say that it is an equivalence relation. Without any doubt, we can say that it is an equivalence relation. It should satisfy all 3. What is that? Reflexive, symmetric, and transitive. Okay. So R is reflexive, R is symmetric, and it is transitive. Then we say it is equivalence relation. Okay. Next, we have inverse relation. People, quickly let's try to move to the problems. Okay, that is more important. So now tell me, inverse relation. What is inverse relation? Right, people, just a minute. All right, people. So now what is inverse of a relation? See, in inverse, the set A becomes set B becomes set A. Simply it becomes reverse. Right? So till now, whatever we're talking, for example, R, which is a relation from A to B, now we need to move for R inverse. R inverse is a relation from B to A. R inverse is a relation from B to A. So whenever we want to find the relation inverse of a relation, the complete domain should be converted to codomain, and codomain will be converted to domain. Okay, from there again range will differ. Okay, so domain of R inverse will now become the range of R. Before the range of R now becomes domain of R, and before the domain of R now becomes range of R inverse. Okay, so domain and range will become range and domain here. And once again you apply inverse, R inverse whole inverse is equal to R. Clear? All right. Okay, so that is about inverse relation and types of intervals. Okay, this is very important again. So when you have let's say from A to B in closed brackets, when I say in intervals, okay, I say x belongs to A comma B. Okay, that means x is a number between A to B. That means A less than x less than B. A and B are not included. We need to consider the elements which are there in between A and B. For example, you have 1 comma 4. So you need to include all the elements from 1 to 4, but not 1 and 4. 1 and 4 are not included. Are you understanding? Let's say 1 comma 4 with square brackets. This is called open interval. This is called closed interval. So in closed interval, 1 and 4 can also be, like they are also included. 1 and 4 are also included. And semi open, semi closed, if you can see. So one side open, one side closed. It is like 1 cannot be included, but 4 should be included. Okay, semi open, semi closed. Or you can have 1 like this and 4 like this. So 1 is less than or equal to x less than 4 in that way. Are you understanding, people? All right. Okay. So let's move forward, students. So we have a question here. Let A is equal to 1, 2, 3 and consider the relation A equal to 1, 1, 2, 2, 3, 3, 1, 2, 2, 3, 1, 3. Then R is reflexive but not symmetric, reflexive but not transitive, symmetric and transitive, neither symmetric nor transitive. So please take your time to tell me what will be the answer for this. Everyone do it fast. And people, as I said you that you should also be aware with the weightage of the paper. Weightage means in which chapter, which type of questions are coming. Either you're getting long answer like 6 marks questions, or you're getting 2 marks, or you're getting 4 marks, or a mix of all them. Although they're not fixed every year keeps on changing here and there. But still, at least the last 2-3 years papers, you should have a grip of that. Okay, so that it will be helpful for your preparation. Right, please tell me. So 1, 1, 2, 2, 3, 3, it is enough to say that it is reflexive. We can have extra elements also, no problem. We can have extra elements also, right? But whatever the reflexive, what we need from 1, 1, 2, 2, 3, 3, we are having. So definitely this function is reflexive. Now we need to think about whether it is symmetric or not, whether it is transitive or not. For symmetric, if 1, 2 is there, 2, 1 should also be there, right? For 1, 2, 2, 1 should also be there, but that is not there. So it is not symmetric. It is not symmetric, right? So, and okay, fine, it's not symmetric. What about transitive? See, 1, 2 is there, 2, 3 is there, so 1, 3 should be there. Okay, it is there. Next, in that way, any other thing? 2, 3 is there. 2, 3, 3, 3, 2, 3. Okay. So I think all other things are valid. Okay. So that can happen to be transitive, right? Reflexive but not transitive, reflexive but not symmetric. I think first option may be correct. Please look into that. Even I'll be checking once. Let me check the answers, what I'm having here. Which question is this? A is equal to 1, 2, 3. Just a minute. Yeah. Right, okay. So that will give you first option, okay. Reflexive but not symmetric, okay. Reflexive but not transitive, but that is not there. Okay, it is there. It is transitive, sorry. It is transitive. So Transitive, this is also not correct. Okay, so reflexive but not symmetric, the first option will be correct. All right. Okay, so let's move for the next question, people. Okay, check whether the relation in the set R of real numbers defined by AB 1 plus AB is greater than 0 is reflexive, symmetric, or transitive. People, 1 plus AB is greater than 0. So we need to have the elements which obey this. Okay, and the relation R in the set of all real numbers. So all positive, negative, everything will come in that. So now check that. For reflexive, if a comma if a if the set has A, B, C, whatever it is, so A comma A should satisfy this. A comma A should satisfy this. So carefully check that, people. Everyone. Do it fast and give me the answers. Okay, so in reflexive, as I said, A comma A should be an element. Okay, 1 plus A square. 1 plus A square should be an element. Yes, it is correct. 1 plus A square is always greater than 0, no matter whatever A you take. Right? A square is always a positive number, so this number will always be greater than 0. Even if A is equal to 0, this number is 1, greater than 0. Correct? Are you understanding what I am saying? Okay, so now this is reflexive. Reflexive is done. Now take about symmetric. Symmetric means if 1 plus A B greater than 0, then whether 1 plus B into A replaced with B, B replaced with A, whether 1 plus BA will be greater than 0 or not. Yes, it will be greater than 0 because both are same. A into B or B into A both are same, right? In that way, what is the next? Transitive, you need to go for transitive. If 1 plus AB greater than 0 and 1 plus BC greater than 0, then you need to check whether 1 plus AC is greater than 0 or not. People, to counter or to say that it is false, one example is enough. But if you want to say it is true, it should be true always. That you need to prove that. But if you want to say that it is not correct all the time, just one example is enough. So think how you want to give me the answer for this. Do it fast. We will just see ABC values. Okay. So for example, A is minus 8, B is minus 1. Two negatives I'm taking. 1 plus minus 8 into minus 1 greater than 0. 1 plus 9 greater than 0. 10 is greater than 0. Correct. Okay. So B into C. 1 plus B into C greater than 0. 1 plus B is minus 1 into C is 1 by 2. So 1 minus 1 by 2, that is 1 by 2 is still greater than 0. Fine. What about 1 plus A into C? 1 plus A into C. 1 plus A minus 8 into C 1 by 2. So 1 minus 4 minus 3 is greater than 0 is wrong. You can take any examples. Well, why this happens is, see, A into B will be positive even if both are negative, right? 1 plus BC will be greater than 0 even if both are positive, or you can also have a chance that one value will be positive but a very small value. Then also I can say that this value will be greater than 0. But that will not happen again when you go for A and C. Okay, so you need to take examples such a way that to say it is true, you need to go in this process. You cannot take one example and you cannot say that it is always correct. But to say it is false, one simple example is enough. Okay, so this is not correct. So it is not transitive. So answer is, it is reflexive, it is symmetric, but not transitive. Clear? Are you understanding this? Okay, let's move for the next one. show that the relation R in the set n cross n, n is the natural numbers, okay? From the natural numbers set is defined by a square plus d square is equal to b square plus c square, a square plus d square is equal to b square plus c square. Is an equivalence relation, okay? So this is your homework. I'm giving this as a homework. So you need to show that it is reflexive. That means if a comma b is there, okay, if a comma a should be there, right? For reflexive a comma a. So you need to see in that way, okay? Reflexive and symmetric, transitive. So all these three should be satisfied. All these three should be satisfied, okay? Right. So the next question. If Z is the set of all integers and R is the relation Z defined by R equal to AB such that AB belongs to Z and A minus B is divisible by 5. Something like 5k. Okay. A minus B is divisible by 5. Prove that R is an equivalence relation. Prove that R is an equivalence relation. Okay. People, first of all, to prove reflexive. To prove reflexive, a comma a element should be there. That means a minus a is equal to 0. Yes, it is multiple of 5. 5 zeros are 0. It is a multiple of 5. Okay, it is divisible by 5. Next, for symmetric, see, we are going with integers only. Okay, don't bring rational numbers and all. Like symmetric means if 10 comma 5 is there, which it says 10 minus 5 is equal to 5, it is divisible. So now 5 comma 10 also you need to check. You need to check for 5 comma 10. So 5 minus 10 minus 5, that is also divisible by 5. Okay, it may be negative, but still okay. It is divisible by 5. Okay. The same way if you go for third, transitive. But people, can you say like that? Okay, you cannot say like that. Okay. So you don't take an example. I have taken just to explain you. So you need to write step by step. You need to write step by step. Okay. So for a comma b, we know that a minus b is equal to 5k. So b minus a will be equal to minus 5 into k or 5 into minus k. So it is still a multiple of 5. It is divisible by 5. So hence it is symmetric. Hence it is symmetric. The same way you need to go for transitive. So in transitive, what you need to prove? In transitive, what you need to prove? Tell me. So in transitive, if a comma b is there, that means if a minus b is equal to 5k and b comma c, b minus c is equal to some, let's say 5 k1, 5 k2 for different constants. Okay. Now using this, you need to show that a minus c is a multiple of 5k. Is a multiple of 5. A minus a, how do you get a minus c? Just add these two. Add these two, minus b and plus b gets cancelled. So you'll get a minus equal to 5 times of k1 plus k2. And yes, you can say that it is a multiple of 5. It is enough to prove that it is an equivalence relation. It is to prove that it is an equivalence relation. Okay, people, the previous question is also very, very interesting. Again, here also, during when you're doing for transitive, you need to take two equations. Like a comma b, b comma c, and then you need to modify that to get a comma c relations. Okay, that's the reason I'm giving you this homework. Beautiful relation. Next, x minus y is divisible by 3 is an equivalence relation. Okay, please try that in the same way. Same type. This as with 5. Now we are going with a 3. Again, it is with integers only. Right. Next. Satisfying AB related to CD if AD times of B plus C is equal to BC times of A plus D, then show that R is an equivalence. Okay, almost the same. Let's move to the next, other than this equivalence, right? The next one is a function. So sorry, there is a mistake. Let me completely erase this. That is good. Alright, this is something like paint. I will write it once again. Okay, don't worry. It's kind of paint, quick. Or let's say I can increase my ink, right? That's good. Okay, so what are we dealing? We're now dealing with the functions, okay? Functions. Sorry for that. Fine. So what is this functions all about, people? So what is the difference between a relation and a function? Now tell me. See, in relation, any mapping between A and B, is considered relation enough. You can have 1, 2, 3, you can have A, B, C. From 1 to A, it is a relation. Good. Even if nothing is there, you can say it's empty relation. Fine. But in function, that is not correct. In function, we need to have all the elements in the domain should be mapped. All the elements in 1 to 3 should be mapped. For 1, 2, and 3, we should have mappings. Okay, A, B, C. For 1, A, 2, C. 3 is left like that. Is it a function? No. Because it is there in the domain. We should have some mapping for that. Then only we can say that it is function, or else it is not. Okay. And now, let's say 3 is connected to B. It is a function. Yes, it is a function. It is definitely a relation. No doubt, it's already a function. Okay. Now, if I write like this, 1, 2, 3. A, B, C, 1 to A, 2 to A, 3 to B. Is this a function? Yes, it is also a function. You may ask, sir, C is left here. Fine. C is left here. Fine. No problem. Nothing to worry. Even if there is an element in the codomain which does not come under range, fine. Nothing. No problem. But okay. So mapped. All the domains are mapped. All the elements in domain are mapped. But you can see from 1 to A, 1 to B, 2 to C like this. Is it a function? No, now it is not a function. Why? Because from 1, we're having 2 mappings. That's not correct. See, these 2 went to C. That's okay. For 2, you got the answer 3. For 2, answer C. For 3, also answer is C. No problem. No doubt in that. No problem. But here for 1, you are getting 2 answers, one with A, one for A and one for B. That is wrong. You cannot have that. In function, it should be unique mappings. That means it should be mapped to only one element. So that's the reason it is not a function. That's the reason it is not a function. Okay, you can see the definition. Okay, each element of A must be related to some element of B. Each element of A, that means every element of A should be related. Okay, but in relation, there may be some elements of A which are not related. That can happen in relation, but in function, definitely it should be related. Okay, next, an element of A should not be related to more than one element of B. That just now I told you. Okay, just now I told you. An element of A should not be linked for more than one element. That's not correct. That's not a function. But here, an element of A may be related to more than one element of B. Any times, any crisscross mappings and everything comes under relation. But they will not come under function. That is the main difference between these two. Okay. So quickly let's try to complete the function. So we know IND function. Okay, f of x equal to x. I of x. I is generally used for IND. But you can simply say f of x is equal to x. Okay, no issues in that. So domain is R, range is R. Modulus x, modulus, absolute value function. Okay, you always get either positive answers or 0 for that. So here the domain is R, range is 0 to infinity. You will never get negative values for mod x. Okay, so mod x is equal to 2. What is the answer? X is equal to plus or minus 2. Mod x is equal to minus 2. What is the answer? X is equal to how much? What value you will keep to get minus 2? What value of x you will keep here to get the answer as minus 2? No. Gone. You cannot get any answer. Then we use this sign phi to say it is an empty relation, empty function. Okay, no elements in that. Next, greatest integer function, step function. We also say it is a step function. Step of 1.5 is equal to 1. Okay, step of minus 1.1 is equal to minus 2. For negatives, you should be very careful. So all the real numbers can come in domain, but the range is only integers. The range is only integers. Okay. Next, in same way, this is not correct. Smallest integer function. This symbol is not correct for this. Okay, like this. You will have like this. Okay, this is exactly the reverse of step x. Okay, if step of 1.45 is 1, the smallest integer function of step of 1.5 is 2. If you don't know this function, no worries. Okay, don't worry. Right, exactly reverse of that. Next, Signum function, signum mod x by x, you either get answers 1, 0 or minus 1. The answer will be minus 1, 0 or 1 only. Okay. Exponential function a power x, logarithm log x, you will only have positive numbers in the domain. Okay. In e power x, you will be having only positive in the domain, in the range. Okay. Exponential function will never give you negative. 2 power x is equal to minus 1. What is the answer? You cannot find that. You cannot get any answer for that. Okay. Provided this base is positive. A greater than 0, not for a less than 0. Okay. Right. Next. Next, types of functions. So 1, 1, many, 1, on to, many, right, into. So 1, 1 function means one element of A should be mapped to one element of B only. We cannot have multiple mappings. Okay, we cannot have like this. All these connected to some element here. No, that's not possible. That's not 1, 1. The function which is not 1, 1 will be called as many 1. The function which is not 1, 1 will be called as many 1. Okay. Right. So in 1, 1 function, if f of A is equal to f of B, then definitely A should be equal to B. So this is the principle we'll be using to prove a function is whether it is 1, 1 or not. To prove a function whether it is 1, 1 or not. Okay. Right. And we have few formulas to find how many elements or how many 1, 1 functions will be there. Right. So it is also called injection. 1, 1 function is also called as injection. Okay. Right. Quickly moving. So the next one is onto. In onto, what happens? The complete domain should have mappings. In other terms, the range should be equal to codomain. What is range? Range means all the elements which have mappings, right? Sometimes function can be, sorry, that's not correct. Okay, function can be mapped like this. Function can be mapped like this, leaving some element here. That's not onto function. In onto function, we should also have a mapping for this. Or complete domain, complete codomain should become the range. Complete codomain should become the range. Okay, then we call it as onto, or we say it is a surjection, right? And a function which is both 1, 1 and onto will be called as a bijective, or we say bijection. We say bijection. Okay, right. Same way, identity relation, we have identity function f of x equal to x. Equal functions, we can say two functions are equal only if they have the same domain and they should have the same range. Okay, two functions f and g are having the same domain are said to be equal if f of x equal to g of x, which means the range should also be equal. Okay, f of x or g of x means those ranges, the function domains and ranges should be equal. Right? Next. That's it. This is again some definitions of that. So domain, codomain, range, we already discussed that for range, so the same thing. Okay, so if you go for let's say as an example, root over 2 minus x. If you want to find the domain of this, what do you do? So 2 minus x, which is there under root, should always be positive or 0, right? It should always be greater than or equal to 0. So 2 greater than or equal to x. So x is less than or equal to, that becomes the domain of this function. So domain means for what values of x the function is defined, that comes under domain, right? And what values we are getting as answers, what answers, for example, I keep x equal to minus 5, minus x, minus 7, I'll be getting different values, right? So all those answers will be considered as range. Understood? Clear? Okay, so quickly let's move to problems. Fine. If the set A contains 5 elements and set B contains 6 elements, then the number of 1, 1 and onto mappings from A to B is 1, 1 and onto means number of bijections. So look into that. Tell me what will be your answer quickly. Do it fast, people. One and on to C. The set A has 5 elements. 1, 2, 3, 4, 5. Set B has 6 elements. A, B, C, D, E, F. Now, for for 1 function, everything should be mapped to only one. 1 to b, 2 to c, 3 to a, 4 to f, 5 to e. But there is no mapping possible for the one more extra element. Here there are 5 elements, here there are 6 elements, right? So we don't have extra element in A, in the set A, so that some mapping can be given to D. Although it is a function, it is 1 1, it is 1 1, it is a function, it is a 1 1, but it fails to be onto. It fails to be onto. Onto means you need to have the same, I mean the codomain and the range should be equal, but that's not happening here, right? So that's not possible. Onto is not possible, so that's the reason we say no 1 1 onto functions, or simply no bijections possible. So it is 0. Okay, it is 0. Sorry. Answer for that will be 0. Clear? Good. What is the next one we are having? Okay, f of x is equal to 1 by x for all x belongs to R. For all x belongs to R, then f is, people, f of x is equal to 1 by x. Fine. For every value of x, you will be getting some value on the other side, right? But carefully observe. Let's say here we are having 1. Here we have 1 somewhere. You will get 2. For 2, we will get 1 by 2 somewhere. Okay. For 0. For 0, you're not getting anything. For 0, you're not getting anything. 1 by 0 is undefined. No. Right. So now tell me what will be done. See, no restriction is given, right? From R to R, it is directly given R to R. Had it been given R minus 0, then we would have thought about that. Okay. It's not possible. Now tell me what will be your answer. Be quick. Be quick. Okay, so in this R to R, there is an element 0 for which the function is not defined. It is enough to say that this function is not defined. F is not defined. Had it been, the question is f running from R minus z0 to R. Had it been given like this, then we can move forward to say whether it is 1 1 or onto or bijective, whatever it is. Because 0 will not be there in the domain, so no need to worry about that. Right? Okay. So here 0 is there in the domain. For 0, you can say that function is not defined. Right? So option D will be the correct answer. Right? Okay. The next. Okay. The same question. Okay. The same question. Okay. F of x equal to x minus 7 by 4 is an invertible function. Write f inverse x. Okay. We need to find f inverse. Okay. So I told in f inverse, the complete domain will become range and range will become domain. Right. So in other words, the complete x should become y should become x. So what we do? See, I will take this 2x minus 7 by 4 as some y. 2x minus 7 by 4 will be writing it as y. So if you write it as y, what will happen? Tell me, what is the value of x from here? 2x minus 7 is equal to 4y. 2x is equal to 4y plus 7. X is equal to 4y plus 7 by 2. Okay, we got x, but what is x? See, if you're taking this as y, we have f of x is equal to y, meaning that x is equal to f inverse y. We can write like this because it was given invertible. Okay, so x equal to f inverse y. So we got finally f inverse of y is equal to 4y plus 7 by 2. 4y plus 7 by 2. So what is f inverse of x? So f inverse of x will be equal to 4x plus 7 by 2. F inverse of x is equal to 4x plus 7 by 2. Just replace the variable, that's it. Okay, don't do any other changes. Just replace the variable. Okay. Right, moving forward, tell me in the next. Okay, so same way, f inverse of x, same way. So you take it as equal to y and move the same process, the before question. Okay. Right, let me drink some water. Okay, please take this question. So A is a function, A is a relation set R minus set 3, B is R minus set 1. So f of x equal to x minus 2 by x minus 3. show that f is bijective. First of all, we need to show that f is bijective. Bijective means we should show that it is 1 1 as well as it is onto, right? So find x if f inverse of x equal to 4 and find f inverse of 7. So please do that. I'll have some water. I'll give you 2 minutes of time, Abel. I'll give you 2 minutes of time. Do it quickly. I know 2 minutes is not sufficient, but don't do elaborately. I mean, don't write step by step now. Okay, you can write that in the examinations or in later in the preparation stages. Do it fast, people. People, drink as much as water as you can every day, every time. Okay, you're sitting idle at home for 2 hours. Drink water after every half an hour, no problem. You're getting washroom, okay, it's good sign. It's good sign that your body is filtering the wastes. Okay, be hydrated, people. I'm saying be hydrated. Be hydrated. I'm not saying dehydrated. Okay. So when you are being hydrating yourself, your brain acts very actively. Okay. Right. So first thing, to prove it is 1 1, I didn't tell you the method till now, but I hope you know by this time that we consider f of, to find whether it is 1 1 function, we take f of x1 is equal to f of x2, and ultimately we need to prove that x1 is equal to x2. If we can bring this, we can say that it is 1 1 function. If we can bring x1 is equal to x2, we can say that it is 1 1 function. So see carefully, f of x1, just a minute, right? Quick. Fine. Okay, so f of x1 is x1 minus 2 by x1 minus 3 is equal to x2 minus 2 by x2 minus 3. So from here, do whatever you want, cross multiply, whatever you want to do. Finally, you need to prove that x1 is equal to x2. So do that. Do that quickly. People, do you know what is componendo and dividendo rule? Okay, just if you don't know, I just want to apply here. So if a by b is equal to c by d, then we can say that a plus b by a minus b is equal to c plus d by c minus d. Okay, that is called componendo and dividendo rule. Componendo and dividendo rule. Okay. So in that case, a plus b. So x1 plus x1, 2x1 minus 2 minus 3 minus 5 by a minus b, x1 gets cancelled, minus 2 plus 3 becomes 1. Okay, so here it will be x2 plus x2, 2x2 minus 2 minus 3 becomes minus 5 by, these two gets cancelled, minus 2 plus 3 becomes 1. Okay, so we got 2x1 minus 5 is equal to x2 minus 5, these two gets cancelled, 2x1 is equal to x2, and finally we got x1 is equal to x2. You may say that this will come for every question. No, there are questions which you will not get. For example, you have squares. So you cannot directly cancel out squares because sometimes you may have negative values. 2 square and minus 2 square are different. Right? So that is, in that case, you should be very careful. Okay. So we prove that it is 1 1. So now how to prove that it is onto function? So in onto function, you know, the range of f will become the domain of f inverse, or vice versa. Domain of f will become the range of f inverse, right? So see, what I'll do, I'll try to bring f inverse for this. Okay, I'll take y is equal to x minus 2 by x minus 3, right? So cross multiply and bring what is the value of x. So yx minus 3y is equal to x minus 2. So if you bring x together, x times of y minus 1 is equal to 3y minus 2. So x is equal to 3y minus 2 by y minus 1, which becomes f inverse of x. So f inverse of y is equal to 3y minus 2 by y minus 1. So f inverse of x is equal to 3x minus 2 by y minus 1. So now you need to think that, again, what is the domain of f inverse? Domain of f inverse is all the numbers. Sorry, this is x. So domain of f inverse is all the real numbers minus set minus 1. Why I am breaking that minus 1? Because it is in the denominator. If I include minus 1, sorry, plus 1. If I include plus 1, the denominator becomes undefined. The denominator becomes undefined. That's the reason I'm not including. So r minus set 1 is nothing but the range of f. So domain of f inverse is nothing but the range of f. So it is enough to say that it is an onto function, right? It is enough to say that it is an onto function. If you can say domain of f inverse is the range of f, it is enough to say that it is onto function. Okay, and now we have f inverse of x is 3x minus 2 by x minus 1. It is given f inverse x is equal to 4. F inverse x is equal to 4. 3x minus 2 by x minus 1 is equal to 4. 3x minus 2 equal to 4x minus 4. So 4 minus 2 equal to 4x minus 2x is x. Okay, x will be equal to, and what is f inverse of 7? F inverse of 7 means keep 7 here. 3 times of 7 minus 2 by 7 minus 1. 21 minus 2, 19 by 6. That is your f inverse of 7. Once again, please cross check that if there is any mistake. I might have done some mistake. I'm not very sure, but please check that. Okay, everyone. Fine. The next. Okay, so again the same type of question table, the same type of question. F is 1 1 and onto means f is bijective. So once again it is, we need to show that it's a bijective. Same process, take it as a y. Okay, and start and find f inverse. Cool. Next. Again the same question. Fine. Next. Okay, f is a function from 0 to infinity to r given by f of x equal 9x square plus 6x minus 5, quadratic equation. Okay, is not invertible. We need to prove that it is not invertible. See, when can we say a function is invertible? When it is both 1 1 and onto. People, f will be invertible only if it is satisfying both 1 1 and onto, simply saying it should be bijective. It should be bijective. Okay, so modify the codomain of the function f to make it invertible and hence find f inverse. So tell me what to do here. We need to modify. Okay, first of all, we need to prove that it is not invertible. How to prove that? How to prove that? Till now, what we did, f inverse. So how to prove? How to find f inverse for this? So equate that to y and try to do it. Please try for some time. Everyone, try for 2 minutes. I'll give you the answer. Do please. Don't waste your time, people. Oh, I'm so sorry. Something has happened. What to do? Which PC? From where this came, I don't know. Fine, please check that. Okay, people. See, first of all, in the same way like we are doing in the previous cases, let's try to find, like let us try to equate that equal to y, and let's try to find the value of y. Okay, so what can be done? See here. So bringing x from here is difficult, but we'll try to make this into some perfect square. So 9x square is 3x whole square, right? 3x whole square plus this is 2 into 3x into 1, right? So plus 1 square should be there, and we'll be left with minus 6, correct? I'm just adjusting these terms. Okay, y is equal to. So I have y equal to, this complete thing is 3x plus 1 whole square minus 6. Okay, so y plus 6 is equal to 3x plus 1 whole square. So 3x plus 1 is equal to root over y plus 6 with plus or minus. 3x is equal to with plus or minus, correct? 3x is equal to minus 1 plus or minus root over y plus 6, and x is equal to minus 1 plus or minus root over y plus 6 by 3. So now my question is this value for all the values of y, do you get an x? For every value of y, are you getting an x? Yes or no? People, when y is equal to minus 6, when y is equal to minus 6 or minus 7 or minus 8, okay, when y is a value less than that, when the y value is minus 7 or minus 8, minus 9, so tell me, are you getting any value of x? When y is less than y is less than minus 6, y equal to 7, 8, minus 7, minus 8, you're not getting any value of x, right? So it is enough to say that it is not onto function. The codomain and domain, I mean that f inverse domain should become the codomain of range of f, right? So that's not happening here. So as it is not onto function, it is not invertible. But had I had this is r minus, okay, r minus set r minus or minus or like I should include only the numbers greater than minus 6. Correct or wrong? Think about it. I should include only the numbers greater than minus 6. Yes or no? So what should I do now? So this r, what can I write? Instead of r, greater than minus 6. So even minus 6 can also come. Okay, minus 6 to infinity. Okay, that instead of this coda minus r, we need to change that to minus 6 to infinity, so that for every value of the range of f will be having it in the domain of f, in the domain of f inverse. Okay, so in that case, domain of f inverse will be equal to range of f. If you have the range as minus 6 to infinity, right? In that case, these two will be equal. Okay, so hence here only it is not invertible, and to get invertible, this is the case. And now to get f inverse, this itself is f inverse. So f inverse of x is equal to minus 1 plus or minus root over x plus 6 by 3. All right, are you all understanding, people? Even minus 6 also can come. Okay, minus 6 can also come here. Easy, not a difficult thing. Okay, right? Next one, 5. Okay, show that f is bijective. So same way we have already done. Okay, show that it is 1 1 first of all. It is 1 1 first of all, and then prove that it is onto. The same way we are doing f inverse and all, right? And then we need to find f inverse of 0, and if f inverse of x is equal to, we need to find x. Okay, right. Next. Okay, f of x equal 5x square plus 6x minus 9. Prove that f is invertible with f inverse of y is equal to, same way, same concept. Just now we had done this quadratic. Just now we had done the same kind of method. Okay, so doing the same way, but this question may take some time to adjust it as a perfect square. Okay, that's the only thing. Composite function. One more thing that we left over. Okay, f of g, f circle g. So here we are having two steps, from a to b and b to c. From a to b, if you take it as f, from b to c, you are having as g. So when you take z circle f, we say z circle f, which is g of f of x. That means first you need to go for f of x. First you need to go for f of x. Once you're done with f of x values, then for that particular value you need to apply g. For that particular f of x, you need to apply the function z. Are you understanding? What is z circle f? Okay, z circle f and f circle g. Okay, fine, people, drink as much as water as you can. Okay, Right. Okay, fine. What else? So this is G circle F. In the same way, you also have F circle G. So in this, you'll be having F of G of X. In this, you'll be having F of G of X. That means first you need to go for G of X, and once you get G of X result, then you need to go for F. Then you need to go for F. So always the inside function should be solved first, and then you need to apply the outer function. So here also, inside G of X should be solved first, and then you can apply F. Understand? Okay. Right. What else we are having? Okay. Same inverse and all. Okay. That's not. We have already discussed this inverse from long time. Okay. If it is a bijection, you know it should be. Okay. We have F of X given and G of X given. So you need to find G circle F. We need to find Z circle F. Tell me what to do. So to get Z circle F, you need to go for G of F of X, right? You need to go for G of F of X. So G of, what is F of X? 3x square minus 5. Okay, fine. What is G of X? G of X is this one. So G of this complete thing means in this value of X, you need to replace 3x square minus 5. So that will give you 3x square minus 5 by 3x square minus 5 whole square plus 1. X by x square plus 1. Understood? You can leave it like this or just solve for one or two more steps. Okay. What next we are having? If f is from a to b, g is from b to c, be the bijective functions. Something missing. Something is missing. Something is missing. People, something is missing here. I'm so sorry for that. It's like then what is g of f inverse? Okay. But I'm not sure, but okay, fine, something like that. Okay. So G of F inverse will be equal to F inverse of G inverse. Okay, please work on that. And again, we're having F of X. G of X is also given. Find G circle F. Okay. There will some printing errors that has happened due to different softwares, using different softwares compatibility. So you need to find G circle F. We already did the same thing before in the same example. Okay. So in that way, people, we have a few more examples and all. Okay. So I hope that will be there in the PPT only. You can try to do them. All right. Fine. So people, what have we discussed in today's class? Tell me, what have we discussed? We discussed what are relations, what are the different types of relations, equivalent, symmetric, transitive, reflexive, and all this will become equivalence, right? And then we discussed about functions, different types of functions, domains, codomains, inverse. Okay, people, in relations, major focus on function will be given. I mean, a relation will be given, and we need to find whether it is equivalence or not. So those type of things. And functions, domain-based questions, and inverse-based questions, and composite functions. Okay, composite functions, G circle F kind of things are very important. Fine. So I hope this video will be useful for you. Okay. So homework is just take your books and try to do all the questions, and please ask me in the comment section if you didn't get any question or any concept. Fine, people. So that's all for today's class, everyone. Thank you so much. We'll again meet in the next video. Thank you.